Good day, and welcome to Africa Teen Geeks. This is a STEM digital school. If you have just joined into this classroom, this is a grade 10 physical sciences class. Today is the 24th of July 2020, and I hope that Friday indeed. I hope that we're ready for some homework. Some test work that we're going to be reviewing today. As you know, yesterday a lot of people participated, and I know email of his paper. And thank you so very much for the effort. It really means a lot to see that there's people that are actually, you know, doing the work. And I know that you guys they have also been doing the work, and you are ready to do some uh, assessment memo today. Thank you guys so much. My name is Nonkulero Matondo. I am your grade 10 physical sciences teacher. I hope that the assessment was very easy for you guys since we've been working on this chapter for so long, these past few weeks. And we're still not finished, with the calculation. We're still left, I think, with the parallel series circuit, but nonetheless, you do understand the concept of series and parallel resistances. I hope that that had made a difference in the assessment when you guys realize what it is that you can do and what it is that is still giving you a hard time. And please, guys, I encourage you guys on your assessment, wherever you got stuck, if there's still some stuff in the chapters that you guys still don't get, please send me a chat so that I can iron it out. I clarify it so that I know once we move from this chapter, we are completely done. We are ready to go forward, and you guys understand each and everything. Any problem, you guys can do. Okay. So our paper was out of 45 marks, and these were the first questions. And these are questions that you guys are going to answer for me. So please open up your chats. So it says on number one, which one of the following statement is incorrect about properties of a physical change? Please, guys, I need you guys to send me the answer that you wrote on the chat. Okay. Which one of the following statements is incorrect about the properties of a physical change? Is it A, when a physical change occurs, the compounds may rearrange themselves, but the bonds between the atoms will not break? B, physical change is in matter is reversible. C, energy is absorbed when matter changes from a solid to a liquid. And D, molecules are not conserved during physical change. So what did you guys get? Please send me A. Please send me your answers now so that we can see how many of you understood this question. You just write A, B, C, or D. Okay, so while you guys are typing that on your chat, let's move to number two. In the compound H2O, the ratio of mass to hydrogen is always A 1 to 2, B 2 to 1, C 1 to 8, and D 1 to 16. So what did you guys get? Come on, guys. Let's be proactive. What did you guys get for these answers? This is multiple choice. I'm just asking you questions on the multiple choice bit. We're going to go back to our normal teamwork where I show you guys and you guys mark your papers. So please let me know, what did you guys get for number one? To what, to you guys in the comment to you guys in the comment of the mass of hydrogen to oxygen. Okay. And then on number three, we have 1 mole of H2SO4. It contains how many? Contains 7 atoms or Avogadro constant, which is 6 times molecules, or D 42.14 times 10 to the power of 23. What did you guys get? Come on, guys. I know you guys did this assessment. How, which answers did you guys get for these ones? Can write with your answers. Okay. So number one, just text it to me. I know you guys did the whole thing. Is through answering questions. So what you guys did, guys, what did you guys get, guys? You need to be confident with your answers. Okay. So no one. Okay. Luckily, A is the correct one for number two, and B is the correct one for number C. So what do you guys say? Do you guys agree? Are you guys together as a team? No words, no answers. Okay, guys, I think this is very easy. Okay. Okay, because we'll get to this one. Okay, and this is our answers. Okay, so number one, you got it correct. It's D. Um, Number two is C, and number D is C. And let's see what that means. Okay, so number one is D. The one that's incorrect is molecules are not conserved during physical change. Number two, it's C. It's 1 to 8. Because here we're talking about the mass. We're not talking about atoms. Talking about the mass. Okay. And then number three is also C. Okay. 1 mole of, remember we spoke about the definition of the Avogadro's constant. We said 1 mole of a substance or 1 mole of a particle, which could be a molecule or an atom, is equals to 6.02 of 10 to the power of 23 molecules, okay, of that substance is the Avogadro's constant. Okay, so here, if maybe they ask something different, that how many moles in 7 or 2 or 3 of H2SO4, but here they said 1 mole. So we know when we talk about 1 mole, they talk about the Avogadro constant, and it's only one of it. Okay. Okay. Um, Waiting once, waiting twice. Any questions? Let's move on. So we move to number two. It says, study the physical and chemical processes below and answer the questions that follow. So this, we've got the first one of a chemical reaction, which is H2O is gives you H2O gas. I think something is wrong there. Let me just check. And then the other one is CO. The other one is CO. CaCO3 gives you CaO plus CO2. Okay. So what they ask here, I'm just looking for the question quickly. Uh, okay. Oh, I do have it right here. I just need to. Okay, so we've got X and then we've got Y. Y is going to be CaCO3 gives you CaO plus CO2. And then on Z, our Z is going to be iron plus oxygen gives you iron oxide, iron 3 oxide. Okay. So what they want to know first is to find the term physical change. Okay. Remember we did this earlier in the course, defining physical change. And then number 2, it says write down the letter of the process that represents a physical change and a decomposition change. Okay. So on number 1, it says a change in which energy changes are small in relations to a chemical change, or number 2, it could be a change in which mass, number of atoms, and the moles are being conserved. Okay. So we move on to 2.2. Um, write down the letter of the process that represents number 1, the following change, number 2, the decomposition reaction. So number 1 will be X. Why is it X? Because you see here, it's H2O solid changed into H2O gas, but the molecules are still intact. It's the chemical that makes H2O is still the same in both sides, right? And then decomposition is why, because remember why big body broken down into small little bodies. It is a decomposition reaction. Okay, so moving on, it says on number 2.3, give the name of the physical change stated in 5.2.1, which is the physical change, and that will be sublimation. Okay, so that's the type of the name of the physical change stated. Okay, so number 4.2.4, state two properties of a reaction that indicate that the chemical changes has taken place. Name the two properties of a reaction that chemical change has, and that would be the color change, formation of a gas, formation of a precipitate, and the change in temperature. So those are the things that can tell you. Okay. Yeah. So you're really coming out very well. Kieran is getting all these answers right. I think Kieran almost got 100% if it wasn't for the multiple choice. But the answers they quite make sense. But I hope that you're fixing the ones that you didn't come correct on as we go along. Okay. So this is our two properties of a reaction that indicate that chemical change has taken place. Okay. So you can choose any two from the change, color, formation, precipitate, change in temperature, etc. So number 2.5 says for process Z, which is this process here, iron plus oxygen gives you iron oxide, which is FeO3. So what they say for process Z, write down 5.5.1 what the symbol H represents. 5.5.2, Write a balanced chemical equation. Show the phases of all reactants and products. Okay, so then we have our iron, and we have our oxygen, and we have our iron oxide. So for the first one, they want to know what does the triangle represent. Okay, so does anybody know what the triangle represents? This is a very simple one, guys. We've spoken about it many times. Does anyone know what the triangle represents? Okay, can somebody please send me a chat of what they think the triangle in a chemical reaction represents? You can even send one word because it's not a big thing. Just send me what you think the symbol triangle represents in a chemical reaction. Okay, let's move to 5.5.2. A balanced chemical equation. Show all the phases of all the reactants. So which means here you're gonna have to write your Fe plus O2 gives you FeO3, and then now you have to start balancing it out. Okay, so I see today nobody really wants to talk. I blame it on the weather. So okay, we'll go. You guys will have to thank once again Kieran for presenting you guys with some answers. So according to Kieran, the triangle is the heat in chemical change, which is absolutely correct. That is absolutely correct. It is the heat, and yes, you see, it is the heat. So there we have it as an answer. So you guys can mark it down if you got it right and write the correct answer. So 5.5.2, where it says balance the chemical equation, here we have it, is Fe plus O2 gives you Fe2O3, right? So to balance out the chemical equation, you have to write, you add a 4 in front of the F, you add a 3 in front of the O2, and you add a 2 in front of the FeO3. Okay, okay. So you almost had it right. Almost, almost, almost. But remember, let me just give you a tip. Whenever you write oxides are always O3, right? Why are they always O3? Because it's stated on the question. You see, this means that your oxide will have a 3 in the bottom. 3 also represent that oxide is O3. So that's why they okay. So that's the only thing that kind of this that you wrote. And that's why your chemical equation didn't come as perfect, but it was very close, very, very close. So guys, please beware that writing down the correct chemical equations is most important. Question is going to be okay. So make sure you write all your answers correct. The correct one. You see, these are exam questions, guys, and tell you they don't always give you an equation. You need to be able to formulate an equation on your own. Okay, so we're moving on to 2.6.1. It says state that the same amount of elements in the same check the question instead of the answer instead of the question. So we're on 2.6. It says a 20-gram sample of CaCO3 in process Y decomposes to form 11.2 gram of CaO. In a second sample, 30 gram decomposes to form X gram of CO2. So So now they want us to state the law of constant composition. And that's where it states that no matter how a chemical compound is prepared, it always contains the same element in the same formation of mass. Okay, are we still good to go? This is 2.6.1. A chemical compound always contains its element in a fixed ratio. That's great, Kieran. You also got it right. So I hope that you guys are also getting these answers right. Okay, so on number 2, they want us to calculate. They say use the law in question 5.6.1 to calculate the mass X of the carbon dioxide formed, right? So now we go. The mass of carbon dioxide in the first sample, they said it's 20 minus 11.2. 20 minus 11.2, because remember, sample of CaO in process decomposes to form 11.2 of CaO, which means the rest is the carbon dioxide, because this is what is formed, right? Let's go back. We formed this and carbon dioxide. So they gave us this one as 20 and this one as 11.2. So because we're doing conservation of mass, because of the law of conservation of mass, if we want to find what is the mass of CO2, we're going to say this one minus the mass of this one will give us the mass of carbon dioxide. Okay, if you don't understand, send me a chat now and I'll go back and explain it again. Okay, so that's what has happened here for us to find the mass. So this is our mass, right? So the proportion of the first sample is going to be 88.8, which is what we calculated there. Remember, we did a whole lot of it. We use molar mass. We take the portion divided by the whole solution of compound. And this is what we get. Okay, so the mass of the carbon dioxide in the second sample is, so basically this is the ratio that we did, right? So here it's going to be 8.8 divided by 20 is equals to x divided by 30. Okay, okay, it's going to be x because the second one is 30, right? The total is 30. So here we've got 8.8 divided by 20 is equal, cross multiply it. Then that's how you get it to be 8 over 8 divided by 20 times 30. And here you get left with your x. And then your x will be equals to the sum of this, which is going to be 8.8 divided by 20 times 30, and it's going to give you 13.2. You guys understand how we got this one? Remember the ratio that we did earlier in the chapter? This is exactly that. That's what is happening here. It's all the ratios where you say x over m is equals to x2 over m, and then you cross multiply because you always have one that is unknown. Okay, guys, I hope your silence means that you guys understand what's going on. Okay, so we move on to number 3. It says a group of learners prepare solution of sodium carbonate by dissolving a 14.2 gram sample of hydrated sodium carbonate in 200 cubic centimeters of water. Explain the meaning of the term hydrated. What is it? What does the term hydrated mean, guys? Okay, so we've got an answer. Somebody says it has water in it. Okay, what do you guys think? it means when the term hydrate. Does anybody know? Guys, this is revision. It's nice when you guys participate so that we can see, how much you know and how much you still need to go forth in learning. Okay, exactly. Our gentleman here is right. He says it's around, it has water in it, and here it says hydrated means surrounded by water. Okay, surrounded by water. So now it says write a balanced chemical equation to show how the solution, how sodium carbonate dissociates in water. Okay, Na2CO3 plus H2O gives you 8Na2CO5. Let's see the equation in this case. So it's going to be Na2CO3. Remember, guys, it's a decomposition reaction. Okay. Okay. So our answer in this case is going to be Na2CO3 will give you Na plus CO3. So it's a decomposition reaction. Okay. Prepare solution of sodium carbonate by dissolving a 14.2 sample of hydrated sodium carbonate. Yes, you see, so they've dissolved this one here in 200 centimeter cube of water. So there you have it. It's going to be right down a balanced chemical equation to show how sodium carbonate dissociates in water. So they didn't want the whole, they just wanted the part that water. So hence we do not have our water here. Okay. So I know guys it's very tricky, but exam questions are exactly like that. They're very, very tricky. So you need to always be alert. Okay. So we're moving on to 3.10 centimeter cube of prepared solution and allow it to complete 5 centimeter cube of what they want to know is define of the molar substance, the amount of substance in 12 gram of carbon 12 complex, but you always need to remember it. Okay. So what type of chemical reaction is represented by chemical equation above? It's an acid base. Okay. It's an acid base chemical reaction. So to calculate the number of moles of hydrochloric acid in is 1 mole per cm cubed. Okay, and there we have it. It's gonna be concentration is equals to um, number of moles divided by the volume of HCl. So everything is given. So we have our concentration, which is 1, and we have our volume, which is 0.005. So our number of moles in this case is going to be 0.005 mole. Okay, you guys understand? It was very simple. It sounded very tricky, but if you just plot what you have, it gives you a very simple answer. Okay. So now they say calculate the mass of sodium chloride formed in the reaction in question 3.3. You see how these questions follow each other. If your first question is wrong, then everything else is going to be wrong in that question. So it's very important that you stay clear and make sure that the answer that you wrote first, you are very sure about. Okay, so we have our mole ratios, which is going to be this one over this one. Remember, our the one who says um, then we can calculate the mass of NaCl. And you know the molar mass, you got it from a periodic table, which you have it right there. And you will have it in a, but in this case, you'd have had to find yourself a periodic table as one of your resources, and that is your NaCl, right? So this is going to be your mass. Your mass is going to be this times this, and this is what you're going to get for your mass. I think that this is enough for today. We'll continue them on Monday again. The rest of the problems, um, we'll continue them on Monday, and then we will see what we do from there. Okay. Thank you guys so much for a beautiful lesson. My name is Donkule Matondo. This is your Physical Sciences Grade 11 class, grade 10 class. This is your Physical Sciences class. Bye. Please do your rest of your questions and make sure that you come back here with some good results. Thank you and goodbye.